In this video, I'm going to show you how to solve the limiting reactant problem from the notes on page 12 and 13. All right, let's get started. Let's take a look at the question. It says zinc and hydrochloric acid react to form zinc chloride and hydrogen gas. If a chemist starts with 20 grams zinc and 20 grams HCl, which is the limiting reactant? Which is the excess reactant? Finally, what is the theoretical yield of grams H2 gas the chemist makes? So before we answer that last question, we have to figure out which of those reactants we're going to run out of first, and that's what the limiting reactant problems do for us. All right, so every equation always, or rather every problem always starts off with a chemical equation, and this one's unbalanced. I'm looking at the right side of that arrow. There's two chlorines. On the left, there's one chlorine, so I'm out of balance. I need to put a coefficient in front of that HCl. Now, each of the zinc, so the other reactants that don't currently have a coefficient, you just assume that there's one. I'm going to write in the 1 in front of each of these just so that we know that they're supposed to be there. All right, so which of these reactants, 20 grams of zinc or 20 grams of HCl, am I going to run out of first? I need to follow the instructions in the notes in order to figure that problem out, that part of the problem out. All right, so let's begin here. Step 2 in our note says convert the mass of the reactants to moles. And so to do that, we take the mass and we divide it by the molar mass. Let's see, we've got 20 grams of zinc from the problem, and the molar mass of zinc is 65.38 grams per mole. I get that number straight from the periodic table, right? It's the atomic number of zinc. Okay, and when I do that, I get about 0.3 moles or so. Now for HCl, let's see, the 20 grams of HCl, the atomic mass of HCl is 36.44. I got that by adding up the atomic mass for hydrogen and the atomic mass for chlorine. So I'm sorry, the molar mass then, and you add those together, is 36.44 grams per mole. And when you do the math, you get about 0.5 moles. Okay, next part. Step 3 says separately divide the mole amounts by their coefficients from the balanced chemical equation. So I'm going to divide this number, 0.3, divided by, see that 1 right there in front of that zinc? I'm going to divide it by the coefficient in front of zinc. So 0.3 moles divided by 1 mole, and 0.5 moles on the other side, divided by the 2 in front. I get 0.3 moles, or 0.3 rather, and 0.25. All right, so step 4 says whichever reactant results in the lowest number is the limiting reactant. 0.25 is less than 0.3. So HCl is the limiting reactant. I'm going to run out of that one first. If HCl is the limiting reactant, that means that zinc is the excess reactant. I have more of that than I need. All right, so I just did the first two questions from that problem. The third question says, what is the theoretical yield of grams H2 gas from the chemist makes? This is now just a traditional stoichiometry problem. Since I'm going to run out of HCl first, I'm going to use that one in my problem when I set up my known and unknown table. Let's go to the next slide just so I can add some more space. Again, I start off with that balanced chemical equation. Put a coefficient of 2 in front. All right, so in the problem, I care about then HCl, and I'm using the mass of the HCl to figure out the mass of the hydrogen gas that I produce. So grams HCl, I'm looking for grams H2. That's my known and unknown table. I'm looking for grams of H2. I know that I have 20 grams of HCl. Now, if you're wondering to yourself, why aren't I using the grams of zinc? It was on the previous slide. I determined that gram HCl is the limiting reactant, and so that's the one that I need to use in my known and unknown table. I can forget about the zinc. I have more than enough zinc. All right, so I care about now the molar ratio between HCl and H2 gas. That's a 2 mole to 1 mole ratio. I need the molar mass of HCl. It's 36.44 grams HCl per mole HCl. And I also need the molar mass of H2 gas. That's 2 grams H2 per mole H2. I'm looking for grams H2. I find it in my last fraction. That gram H2 is on top, so I'm good to go. I don't have to flip it. But I need to now cancel out that mole H2. I can use the molar ratio for that part. Now I need to take the reciprocal of the molar mass for HCl, and finally the grams of HCl I have available. Hey, this is my favorite part when I get to cancel out my 4 fractions, leaving grams H2. Alright, so when I multiply 2 times 1 times 1 times 20, I get 40 grams H2. When I multiply 1 times 2 times 36.44 times 1, I get 72.88. I work from the top down. When I put that into my calculator, 40 divided sine 72.88, I get about 0.5 grams H2, and that's the final answer. Try to do this, the second problem on page 12 by yourself. Use me, use the people in the classroom to help you out. And if you have any questions, let me know.